Hi everyone, I'm Tony Lyons and welcome back to the CG Compositing series. In this video, we're going to be continuing with the Material AOV section in talking about albedos and raw lighting. In previous videos, we went over the simple breakdown, which was the diffuse, specular, and emission. Then we broke it down further to intermediate, which was the direct lighting and indirect lighting. And now we're moving on to the complex level, which involves raw lighting and albedo or texture maps. And here, once again, we're looking at the bigger overview of the diffuse and specular and emission buckets and how those render passes are falling into which bucket. And we're going down into the complex level, which would be kind of the smallest component that you can find in these render passes, which would be the albedo and texture maps and the raw lighting. So we're breaking these bigger buckets of diffuse and specular into smaller and smaller components. Okay, so what is albedo? Very fancy word. So what does it mean? An albedo map is the base color or texture map that defines either the diffuse color or the specular tint of the surface. Remember that in physically based rendering, or PBR, depending on whether a material is metallic or dielectric, non-metallic, determines whether the albedo color is used as the diffuse color or the specular color. It knows what to use the albedo for based off a black and white metallic map. So here we have an example where we have the albedo map with the color information, and then the metalness map is showing you what part of the object is metallic and what is not on a black and white map. Whatever is white is metallic and whatever is black is non-metallic. And this metalness map determines what to use the albedo color for, either as the diffuse color or as a tint to the specular reflection. What's the difference between albedo and diffuse? Diffuse contains lighting and shading information such as highlights, shadow, and light color. It's the object's color or texture in the lit scene. An albedo map is basically the object's texture as it would appear under uniform lighting without any influence of shadows or highlights. So here we see an example of a texture map, something that would go into UV space on a 3D object. And we can see the old diffuse map, maybe before physically based rendering, had still some of the shadow and the highlights from the photography of the brick wall. The albedo map, on the other hand, is supposed to be just the color information, as if the brick wall was completely uniformly lit and had no lighting direction or shadows or highlights, and it's just completely flat. And what would that color of the object be in that scenario? And here we see an example of albedo from a render pass, so after it's been rendered already. It is the texture without any of the lighting information. So you can see the diffuse has the shadows and the highlights, and the albedo in this case is just showing you what the texture would be, like the texture from UV space. So without any lighting information, just what does this object look like with only the texture applied. Other names for albedo. So as usual, everyone likes to name things differently. But I think you're going to get a pretty good idea of what this is just based off these other words. So other words for albedo you might see texture, color, base color, diffuse map, raw diffuse color, diffuse filter. Common terms that you might see being used for albedo would be map or filter. So anything like X map, something filter, that would be pointing to the fact that it is a albedo map or texture map. We can jump into Nuke and see what some of these renderers are calling the albedo map and what they look like. So here we have the fruit bowl redshift render, and it is calling the albedo, in this case, diffuse filter. So I'll go back and forth here, and you can see it's just a uniformly lit like texture map here. Here is the diffuse pass for comparison, and here is the albedo pass. So you can kind of see it is the diffuse pass. It almost looks very similar, but without any of the lighting information. So it's just the texture and none of the kind of bump mapping or highlights or shadows or anything like that. But it is very similar to the diffuse. Here we have the Arnold fruit bowl render, and in this case it's called diffuse albedo. Very clear what it is named here. And once again, I'll give you a comparison from the diffuse pass and the albedo pass. So again, sort of removing any of the lighting and shadow and highlights from that diffuse pass and just ending up with only the texture. And for good measure, here's the Octane, and Octane is calling it diffuse filter beauty. So some similar terms there. Again, the word filter here is doing some heavy lifting. And then we have the diffuse pass and the albedo. So very similar things going on between the Redshift Arnold and Octane renders. Going back to this Blender room example, we have an albedo map called Studio Diff Call. So I think in this case, Studio is just the name of the scene or something, so we can ignore that that prefix there. And it's just calling this diffuse color or diff call. And for comparison, here is the diffuse of the scene, and here is the albedo. So we can see that the wall, for example, a lot of the detail is coming from the lighting information, and the wall is just a solid color, right? It's just this kind of teal blue, bluish aqua color. So same with kind of the plants and the wood texture. A lot of the shadows and I don't know, contours and lighting of the scene is being applied, but you can still tell that you know, without the lighting and with the pure texture, that's what the albedo pass is looking like. So it's a bit more visual of an example of how different the albedo and the diffuse pass can be, but you can see that they're still connected to each other. So here we have this nice V-Ray architectural renderer, and in this case, confusingly, the albedo is just called diffuse. Maybe that's a mistake, I don't know, but it's referring to obviously the texture of everything. And in comparison, here is the diffuse pass. So you can see, once again, the diffuse pass is the texture pass with lighting information. Once you strip all that lighting information, you're left with just the texture, just the material color of the objects. What is raw lighting? Raw lighting is the pure lighting information of the scene without any specular object colors or textures. It is a pass that describes how light is affecting the scene. This pass, multiplied with the albedo, the texture, makes up the diffuse pass. When we're talking about raw lighting, in this case we're talking about the raw diffuse lighting. Okay, so to describe what raw lighting is, I'm just gonna make a simple demonstration here. And I don't have anything too fancy. I have a sphere with a checkerboard on a blank plane on the ground with a scanline render. So there's no lights in the scene here, it's just showing you the pure texture as a result. And before I continue with the example, I think we should go over some math mantras. These are things that you absolutely must know as a compositor, and it's very basic math, so don't worry, but it's always good to repeat it and reinforce it. So anything multiplied by 1 is itself. Anything multiplied by 1 stays the same and is unaffected. X times 1 equals X still. It does not equal anything else. Anything multiplied by 0 is 0. Does not matter what the starting number is. If it's multiplied by 0, it becomes 0. We do not see anything that is 0. It becomes black or null. So using those principles that we just learned, let's make a constant, and the constant is going to be the same size as our shot here. We're going to make it 1, not 10, 1. So now this is 1. What happens if I multiply this image by 1? I'll go to multiply. Nothing, because it stays the same. Anything multiplied by 1 is itself, so it does not change at all. Now this next part should be really familiar with you if you've ever used Photoshop layers and blending operators. So usually if you want to paint some shadows in Photoshop, you would make a layer and then change it to multiply and then kind of paint on that layer. So we're going to kind of do the same thing here. So we have our multiply, and at the moment it is unaffected, but we can make a multiply node and we're going to change that all the way to 0. And we're going to plug in a roto paint into that. I'm going to change the opacity to 0.1. And so what I'm doing here is I'm sort of revealing the multiply of 0, and I can sort of paint a shadow on this sphere. So I can give it some contact shadows and stuff just by painting it with a regular brush. And we can kind of give it a lighting direction here. So I'll zoom in and I'll really focus on some contact shadow here. And yeah, it's going to look kind of messy, but I'll do my best here to give it some kind of realistic looking shadow. Maybe extend out that a little bit, maybe a little bit darker. And I'll give it some kind of shading on this sphere, directional shading if I can. And so I'm just lightly using my Wacom pen to paint some lighting direction here, only focusing on the shadow. And you know, you want to get the surrounding area And so it's taking some shape, you know? It's looking like I'm painting it by hand, but we're kind of getting an idea here. The light is coming from the screen left side, and it is, you know, slightly behind the sphere, maybe coming from over this area here. We can also add like a ramp here, for example. So we could say that the right side of screen is in general in shadow, and we don't have to make it too chaotic here, but maybe something like this. So we have some basic lighting direction here. And how do we paint highlights? Well, it's basically the same thing. So we had 1, and then we had a rotopaint node connected to the multiply mask to 0. We can multiply it up. Let's say we want this to be maybe 4. And we're going to plug that into a rotopaint. Do the same thing. We're going to change the opacity down to 0.1. So my brush is kind of barely having an effect. I have to kind of layer it on. And now we're going to kind of paint some highlights on the sphere. And I'll try to make it a little bit softer here, but let's just say that this side is getting brighter. We'll make it more on the top. And yeah, I mean, I'm already kind of liking the way that this looks. And we can kind of do the same thing as that ramp. So I'm going to copy and paste that. And instead of on the right side of the image, I'll just flip it. So we're making the left side of the image a little brighter. And I won't make it that intense. Maybe I'll do something like that. Okay, so I have my kind of final result, my hand-painted sphere shadow. And we started with this completely, there's nothing going on here. There was just all the same color here, 0.5. And we have painted our light and our shadow. And more importantly, we painted it on top of this constant, which was white. And what did we end up with? If we look at this multiply, what are we multiplying this image with? We're multiplying it with this. And this is a little misleading because you clearly see the dark, but you cannot see where I've painted my highlights, because anything above 1 in the sRGB viewer is gonna look like white because it can't show you anything above 1. It's clipping at 1. But if I gain this down to say 0.3, you can see my paint strokes of where I was lighting this. So if you turn the gain down of the viewer, I'm not changing the values, for example. They're not changing at all in the actual numbers. It's just the perception of what is going on. But you can see that I have both shadow and highlight. And this image that I'm left with here, which has both numbers above 1 that are 1 and that are below 1 that are approaching 0 or that are 0. Those numbers, all this is lighting information. This is a raw lighting pass. So I have gone ahead and applied the same concept that we just did with that simple example, and I've taken the diffuse filter, so the albedo of the fruit bowl render, and I've done the same thing. I have the constant, and then I'm painting some shadows and painting some highlights, and I'm ending up with this scene here, which, yeah, it looks pretty ridiculous, but we can see, what am I painting here? Highlights. So we can see if I make this a little brighter, I'm making the table brighter, and yeah, I was just going in and kind of painting some highlights on some different areas. And I've shaped the same way that I did with the sphere example. I've shaped this fruit bowl to kind of look, you know, like it has a specific lighting direction and give it some shadows and stuff, so you can kind of see what's going on. Now I'm gonna look at this. I'm gonna lower the gain, and we're gonna see both the values that are above 1 and the ones that are below 1, so we can see kind of the range of this image. So again, this is what white would be in this case, and then I have the shadows and the highlights, so we can see both higher and lower than 1. And now I'm going to take this image and I'm going to compare it with the raw lighting of the fruit bowl render. So if I look at the raw lighting of the fruit bowl render, it looks like this. And again, the gain is down. So now for context, I'm going to set the gain back to normal. and we can see we get this completely blown out image, right? It just looks completely white except for the shadows. And we're gonna look at my image here too. And yeah, I have more shadow information there, but you can see my example was also blown out. And just so you know, just because it's white, it doesn't mean there's not information there. It's above 1 and we can't see it. So we have to lower it. But you can see that this raw lighting is pushing and pulling values above and below 1 and shaping and colorizing the information to describe where the shadows are and where the highlights are and what the tint of the light is and kind of what to multiply the fruits by to give it the color of the light. That's why we're getting all this color information here. So it's both shadows and highlights, and it's also the tinting of the color depending on the color of the light. So I hope that kind of explains what raw lighting is, and that you shouldn't be scared when you just see this kind of all white blown out thing. This blown out image is blown out because it wants the values to be above 1, because a value of 1 stays the same and anything above 1 gets brighter and anything below 1 gets darker. So now that we've seen what raw lighting is and what the albedo pass or the texture pass is, how are they combined? The albedo and the raw lighting are always multiplied together, not plussed. And when you multiply the albedo with the raw lighting, you get the diffuse pass. So diffuse is equal to albedo times raw lighting. And we can see this beautiful graphic here. So this is the diffuse pass, and it's made up of the texture, the albedo, and it's multiplied with this raw lighting. And then if you multiply those together, you get back to the diffuse. So why are they important? Raw lighting and albedo are used together to produce the diffuse pass. One is a texture or material color. The other is lighting information. Together, they represent a lit texture. Albedo shows the true intended color of the object material, while raw lighting shows the true colors and intensities of the scene's lighting conditions. Together, they show how that object and material would look in that specific lighting situation. So going back to our fruit bowl, we have our raw lighting, and then we have our albedo, and if we multiply those together, we get the diffuse pass, and I have the diffuse pass, which is just the diffuse plus the subsurface scattering, and this is the redshift example that they were separated on. So this is my diffuse pass that you'll remember maybe from the previous video, and we can see that I've gotten the same result. So the raw lighting times the albedo equals back the diffuse. We can see the same thing here with the Arnold render. We have albedo and raw lighting, and we have the diffuse pass just pulled out here, and we are getting the same result. And we have the octane render, the raw lighting, and the albedo, and multiplied together, we get the diffuse. This example might be more obvious to show. So we had that albedo, and this is what the raw lighting looked like. So it's really giving a lot of details into the scene. And again, this is not white, but it is values above white. So if I gain this down a little bit, you can see all the detail in the plant and the wall. And so this is the raw lighting for the Blender scene. And multiplied together, we get the diffuse pass. And here is the diffuse pass by itself. You can see they are one-to-one the same. So the raw lighting times the albedo equals the diffuse. Here we have that V-Ray render of the architectural scene, and we have the texture albedo. This is what the raw lighting looks like. It's a really nice lighting in the scene. And multiplied together, if I put this back to 1, we get the diffuse. What is raw specular and specular filter? So just like we previously looked at the raw lighting plus the albedo created the diffuse pass, the specular pass is created with the raw specular multiplied by a specular filter. Usually for specular you see the word filter instead of albedo, but they kind of mean the same thing. This is very similar to the concept that we just went over, except for raw specular is more like rendering things at 100% reflectivity. So it's as if a chrome shader was on everything in the scene, and it is reflecting everything to the absolute max that it can. And then it takes the specular filter, which is kind of acting like a mask, and it's limiting where you will see that 100% reflectivity. So things that are whiter in the specular filter will be more reflective, and things that are darker will be less reflective. In this specular filter, for example, you can see that there is a Fresnel effect on the fruits. So when you get closer to the edge of the fruits, as you can see on the actual specular pass, the specularity or the reflectivity will be higher on the edge than it would be while it's facing us. So once again, raw specular is like 100% reflective material on everything, and then the specular filter is limiting how much of that reflectivity you will end up seeing. And similar to the raw specular and specular filter, we also have raw reflection and raw reflection filter. And it's the exact same concept as the specular. So this naming is depending on the renderer. Sometimes you'll see specular, sometimes you'll see reflection. But it basically means the same thing. It's the same concept of like a 100% reflective material, and then a filter that's limiting that. More importantly, when you have a render pass with like raw in front of it, raw reflection or raw specular, and then you also find another pass with a specular filter or reflection filter, what you need to know is those two get multiplied together to create the actual reflection or specular pass. Let's take a look at some of those raw specular and filter passes from our renders. We have the Arnold fruit bowl render. This is what the raw specular pass would look like. You can see it's very bright. It's almost as if a chrome shader was put on every single object. So it's 100% reflective and specular, like to the max. And then this is our specular albedo. Once again, you can see that the edges of the fruit, because of the Fresnel effect, where things get brighter along the edges that are facing away from us, those are going to be brighter, and they're going to be multiplying up the raw specular pass. So we have the raw specular pass and then the specular filter, which is guiding it or masking it to only be 100% reflective in certain areas. And so if I switch the multiply inputs around, you can see if I use the mix, we're kind of controlling, I guess, how much reflectivity is everything from 100% down to the reasonable level that it was rendered for the materials. And here we have the Octane football render, and you can see this time it's using the words reflection and reflection filter beauty, and it doesn't even look the same as the Arnold render did. So this is a much more like basic version where it's just white and then some lower color. So if you look at the raw specular, it looks something like this, and when you multiply, only the fruit bowl itself is getting darker. So you can see it's multiplying that down because it had I guess, less of a specularity or less of a reflection than the rest of the items. So even the two specular filters look quite a bit different. So I guess it really depends on the renderer or how it's set up. And sometimes you don't even get the specular filter at all. So yeah, it's just something that you do see. And if you do see it with the raw, then you multiply them together and you end up with the specular pass. And you can see that the raw specular times the specular filter is actually recreating the specular pass. So if I just pull out the specular pass with a shuffle, you can see that it is one-to-one recreating that. So the Blender scene might be a slightly better example of this. And in this case, specular is called glossy. They're synonyms, so glossy and specular being the same thing. It's just the Blender term for it. So you can see here, this is the raw specular, and once again, it's kind of like this chrome shader. Everything in the room is 100% reflective and specular. And then we have this specular filter, which is doing a good job of showing the kind of the angles and the Fresnel effects, especially on the chair and on the table and on the table legs. So some of the items, these are the metal items of the scene, and those are much brighter. The handles on this dresser and on this little stool stand. So once this multiplies, you see those items the most. They kind of pop out, those little dressers, whereas everything before was kind of uniformly specular. So the specular filter tends to be brighter on these metallic items because they would be, the most specular thing in the scene. We can see if I add like a roto paint node to the specular filter, I'll bring this down quite a bit in opacity. Let's just add everything else back in the scene. You can see if I paint on this layer, that I'm increasing the kind of specularity of some of the items. I'm turning things into kind of a chrome shaded. Maybe the plants is a better example, but it doesn't take too much to get this to show up. But yeah, this is a way I'm kind of like painting specularity back, I guess, in this case. So yeah, that's the relationship between the specular filter and the raw specular pass. We must also be aware that the raw lighting, just like the diffuse lighting that we learned in the last section, can also be separated into direct and indirect. So we would have the raw direct diffuse and the raw indirect diffuse, and combining those together would equal the total raw diffuse. They are just added together, they're not multiplied or anything. It's just combining them together to equal all of the raw lighting. They are still both using the same albedo pass. There's not like a separate albedo pass. So these usually get combined together and then multiplied with the albedo pass. For our purposes here, if I just say the word raw diffuse, I'm just referring to the total raw diffuse. I'm not too interested in separating them unless I specify it. So the only example I think I have of this is the Blender example, and here we have the direct diffuse raw lighting pass and the indirect diffuse raw lighting pass, and they're both added together here to create the total lighting, and that is then multiplied by the albedo here. So they did come separated, but it's easy just to plus them together and then do everything at once with the multiply. And wouldn't you know, if you can separate the raw lighting into direct diffuse and direct indiffuse, you can also separate the raw specular into direct specular and indirect specular. Again, it's the same concept going on, it's just that sometimes they are separated into direct specular and indirect specular and then need to be combined together and multiplied with the albedo. So once again, in the Blender room, we have this specular direct pass and the specular indirect pass. So that's all the reflective bounce specular lighting there. And those get added together, and they both use the same specular filter, which was this guy here with all the Fresnel. And so same concept as before, we can be adding in the indirect. So we combine them first, and then they both use the same specular filter. Okay, for this next section, we're going to jump back into math class. Please don't get scared. We're just going to go over some very, very simple equations here. We're going to define a couple of variables here. So I'm going to use X for albedo and Y for raw light, or yellow and blue here. And so our diffuse pass equals our albedo times our raw lighting pass. So we just went over all of this. It's nothing new. I'm also just going to simplify it to diffuse equals X times Y. So X and Y are representing albedo and raw lighting. So just a little simple equation there. So far, we've learned what to do when you get the actual passes in their smallest components. So if you had an albedo pass and if you had a raw lighting pass, you could multiply them together to get the diffuse. But what if you only had the diffuse pass and one of these extra passes? How could you separate this out into their individual components? And we're about to go over that. Right, so in math class, we learned that operations have opposites, so they can undo or reverse any operation. So, for example, we have addition and subtraction. So if you do x plus y and then you minus y, well, the y's cancel out and then you get x isolated by itself, right? So 5 plus 8 minus 8 is still 5, right? So the 8's cancel each other out and you get the same number. Now multiplication, the opposite of multiplication is division. So x times y divided by y, the y's cancel out and we get x. So yeah, how to reverse a multiplication is division. So let's go back to our little equation here where diffuse equals x and y, x standing for albedo and y standing for raw lighting. So here is again the equation that we just covered. X times y divided by y, the y's cancel out and you get x. X times y divided by x, the x's cancel out in this case and you're left with y. So you're just going to divide by the one that you don't want and you'll end up with the pass that you do want. So if we look at the full equation here, we have the diffuse pass, which is both of them combined. So diffuse divided by raw lighting, so then we cancel out the raw lighting and all we're left with is the albedo pass. And the opposite of that would be diffuse divided by albedo, and then we get only our raw lighting pass. Okay, we've survived the math class example, so let's jump into Nuke and break this down and show an example of what we were just talking about. We have the Blender room here, and we have the diffuse pass and the albedo pass, and we know that we can get the raw lighting by taking the diffuse and dividing it by the albedo pass. So A divided by B, diffuse divided by albedo, and we get the raw lighting as a result. The other way around would be we have the diffuse pass, and here we have our raw lighting. So we had the direct diffuse and indirect diffuse raw lightings, and we plus those together. So that's our total raw lighting. And then we have our diffuse pass divided by the raw lighting, and we end up with the albedo. And I'll take this albedo shuffle so we can actually shuffle out the albedo. And you can see, if I compare these, that they end up being 1-to-1. I'll show the same thing here on the specular. So let's just say we had our specular pass together, and then we have our specular filter. We can get our raw specular by taking the specular and dividing it by the filter, and now we get our raw specular, which was that kind of chrome shaded 100% reflective environment. And vice versa, if we had our specular pass and the specular direct and specular indirect, which combines to the raw specular. So say we did have the raw specular, now we can get our specular filter by taking it in and dividing it by the raw specular, and then we get our specular filter. And once again, I will plug in the actual specular filter, so the shuffled out version, and we can see that they're 1-to-1. So the math is checking out, and that's quite important because sometimes we are missing a pass. And if we're missing a pass, we don't need to freak out. If we have at least one of these, if we have either the specular filter or the raw specular, we can always get the other one by taking the main, like the specular, and dividing it by either one, and then you're left with the opposite. So we're able to split it apart even though we're not rendering the individual component. So there's no need to throw your hands up in the air or yell at your lighter. If you have the diffuse and you have your albedo, you have everything that you need. You can always get your raw lighting pass. So we don't always need to build it up using the little components. We can also take the bigger item and break it down into smaller components. Division, however, is a little bit more complicated than multiplication. So we're gonna go back and reinforce some basic math ideas here. 0 divided by any number is still 0. So if you start with 0 and you divide any number, it's still 0. However, you cannot divide by 0. You can't go the other way around. So if you start with any number and it's divided by 0, it does not equal 0. It equals undefined. It's impossible to do that. So if you think of the question, how many times does 0 go into 4? It's really impossible. You can make an infinite number of zeros and they still wouldn't go into 4. So if we took 4 and divided by 0, it's not equal to 0. It's equal to undefined. It's not possible in math to do it, and that creates a little bit of problems with this division. So you can run into some problems here. So it really does matter which order you do the division. 0 divided by any number is okay, but any number divided by 0 is not okay. Okay, so let's see how this division problem manifests itself inside of Nuke. And so to test this, we're going to start with this color wheel. We're going to look at this expression node, and I'm using an expression node because it's kind of just pure math. It's forcing the math down Nuke's throat. So whenever you're using an expression node in Nuke, there are certain variables that are built in by default that will be recognized, and R, G, B, and A stand for red, green, blue, and alpha. And so this expression node is reading something like 0 divided by red, 0 divided by green, 0 divided by blue, and 0 divided by alpha, and it's doing that on a per pixel basis. Now, it looks like the 0 divided by this color wheel. It looks like that is pure black, but it's not pure black. In this color wheel, we have actual values that are 0. 0 divided by 0 is not 0. Anything divided by 0 is undefined. And so here, if we actually look at the values inside of that color wheel, we have 0, but outside of it, where the black was, we have non. So all these channels say non. And non is not a bread from India. It is not a number. So this is that undefined. This is how Nuke is interpreting this this non-numerical value. So it can't do it. It doesn't know what to do. It just says non. Here in this node, I have a little expression that is testing whether or not it's non-pixels or inf pixels. Inf stands for infinity. Basically, even though this looked like black, if I add this expression here, if it's not a number, it shows up as white, and if it's a regular number, it shows up as black. So this is actually letting me know that I have illegal values in my image, and that's a big problem. If you have been a compositor for a few years, you might have encountered a non-pixel, and for example, if you try to exponentially blur a non-pixel, you end up with not a number everywhere in your shot and it kind of explodes in your face. So non-pixels are very bad because it can't continue doing any more math with this thing because it's not actually a number to do math with. Okay, on the other side of that, we're going to look at this other expression, which is we start with the color wheel, and we're going to divide it by 0. And we already know that you cannot divide by 0, and this is the actual result of that. It looks white and black, but again, if you hover over the values, we have infinity, inf, INF, and none. So anything that was black, the same as before, is getting not a number. And now inside of the color wheel is inf. Why is it inf? Because any number, let's say you have the number 4, 0 goes into 4 infinity times. It can't really do it, so it just says infinity, which is pretty much just as bad as non. So we have like the opposite end of the spectrum. It's like it could do it infinity time, which is not really a number, and then it can do it not a number time. So trying to divide by 0 inside a nuke is definitely not a good thing. So you might say to me, Tony, I've used nuke for a very long time, and I've used the merge divide, and I never see this issue popping up. I don't know what you're complaining about here, and that is true. The Foundry and nuke itself is smart enough to know that when you're dividing, you don't want not a number or infinity pixels. So the merge node, when you do a divide, so I have this color wheel, and I have 0 value pixels in this checkerboard. So the dividing by 0 should give me either infinity or not a number. But if I do a merge divide, so the operation that you can find right here, merge divide, I don't get crazy numbers. I get reasonable numbers here. Even in the outside, I get 0. So it's built in to the merge node to not give you those values. So basically the merge divide inside of nuke has some protections in it. So as far as I can tell, 0 divided by 0 gives you 0, and any other number divided by 0 gives you back that input number. And we can kind of see this here. So let's zoom into a part with the black 0 pixel here. So here I'll just sample some values, and I'll go after the divide. Those values did not change. So even though we're dividing by 0, we didn't freak out with an illegal value. We're just giving it back the same result, unchanged. And here's my little tester to see if it's giving me any not a number or an infinity values, and it's fine. It's nothing is illegal here. It's coming out as black, so that's great. If you use merge divide, you have nothing to worry about. Absolutely nothing. You can divide by 0 as much as you want and never have an issue. There is, however, a limitation to the merge divide, and that is that it always goes to the B input. And the way that we need to read this, because we know that doing a divide the other way around, so if I switch this, it doesn't give you the same result, right? And who cares? You just always plug A into the right spot. But what if when I disabled a node I did not want to go to the checkerboard? Instead I wanted to go back to the color wheel. If I disable the node, it goes to B, and in this case, B is checkerboard. Unfortunately, there is no way to switch these inputs like you normally can do, because in this list of operations, I'll let you pause the video and check, there is no B divided by A. There's only A divided by B. And so we have a bit of a problem here. If we want to disable this and go back to our checkerboard, we need to find kind of another solution to that, because this only is able to divide in one direction, A divided by B. So we kind of want this setup here with the A input going into the checkerboard, so that when we disable it, we get our color wheel back. But we'd like it to be B divided by A instead of A divided by B. So we could make this solution ourselves with a merge expression. So we're taking the expression node and combining it with a merge node, and now it's taking both of these inputs into consideration. So it looks exactly like the expression node. So this merge expression node has the same access to the variables that the other expression node had, which was RGBA equals red, green, blue, alpha, except for this merge expression has 2 inputs, A and B. And so capital A stands for input A, and capital B stands for input B. So because there is a red channel in input A and one in input B, you need to specify which red channel you're talking about. So you would do it by doing capital A R, and that would be input A red channel, and capital B G, for example, would be input B green channel. So essentially what we're doing here in this expression is we're taking all of the B channels and we're going to divide them by all of the A channels. So for example, we have BR divided by AR, BG divided by AG, etc. After we've done all this, we have now a B divided by A divide node, which looks pretty nice. However, with further investigation over these seemingly white and black values, we can see that we have the same issue that we had before, because it's running into that same problem that we had with the normal expression nodes. So because we're doing the math manually, nuke is giving us the mathematical answer, which is to go pound sand, which is that you can't do it. So we're getting this not a number value and this infinity value. And if I look at these illegal pixels, you can see my image is now full of values that are not numbers anymore. So we need to fix this. So if we want this, the benefit is that we can disable this and it goes back to B. So that's really nice. But it's giving us all these problems, but we can fix it. So in order to fix this problem, we need to do a little bit more TCL, and we're doing an if-then statement. And I've highlighted them right here. And the way to read this expression is kind of as follows. So we have B divided by A, and so only when the A input is 0 are we going to have a lot of problems because we can't divide by 0. So we're going to test if the pixel value from A input is 0. So we say, is the pixel value from A 0? In that case, just be the result of B. So just stay the same. So, don't even try to do any math. Just show me the same exact thing that was already in the B input. Otherwise, if it's any other number besides 0, just go ahead and do B divided by A. So it's just checking first if the A input had any 0 values. And it's telling it, okay, so if you have a 0 value, just remain the same. Don't even do the math. And that is kind of the fix. And again, here is the equation for those. I can put the fixed version of this next to an actual divide. So this is the merge divide, and you can see that they are the same. I can probably do a difference node, and there is no difference between the two images. So it's doing the exact same result as a merge divide. But we have the benefit, if you had the merge divide, it's always going to go to the B input, which was the checkerboard in this case. But now we have this merge expression, and when we disable it, it goes back to our color wheel. Now that the inputs are switched, instead of A divided by B, it's B divided by A. And that allows us to disable and choose which pass we want to show when disabled. So we can pass through to whatever we want to show when it's disabled. I actually use this merge expression divide quite a bit, and I've made it into my own toolset here called merge divide, and it's going to be the exact same result of what we showed. So I could throw this on Nukepedia or my Compositing mentor blog and give you a link to this so that you could save it into your toolset yourself. It is just this merge expression node with the expressions plugged in, but it is handy if you don't feel like remembering the expressions and just to have it ready at a moment's notice. I'm going to introduce one final concept that I think is going to help us when we're looking at these rebuilds, which is the relationship between multiply and divide. So you can think of multiply like combining or fusing, mixing, linking, joining, locking. It is the melting pot. It's bringing those things together. You can think of divide like separating or splitting apart, unlinking, disjoining, unlocking. So it's breaking those smaller components apart. So our workflow here using multiply and divide is going to be to separate, change, and recombine. We're going to start with the combined pass, like diffuse. We're separating with division, so it's splitting these apart. Then we're going to change the individual components. So here I just have a little graphic. I'm changing blue to green. And then we're going to multiply it to bring it back and fuse it back together. Separate with division, change, and recombine with multiplication. Alright, we've talked about what the albedo and the raw lighting is, how to find it, how to combine them together, how to separate them. So let's now talk about why to use the albedo or the raw lighting pass. So why do we even need them to be separated in the first place as a compositor? So how is it going to be useful to us? Alright, so let's say we have this Blender room and we get some note that we want the wall color to be white and the table color to be white. It's some off-brand of wood that is completely desaturated. If we were to use just the diffuse pass, and here I have a mask for the tables and the wall. If I plug in a desaturation into that and desaturate it fully, but it sort of looks a little out of place. And the reason for this is because I'm not only desaturating the material of the wood, I'm also desaturating the color of the light. So this result is kind of breaking reality because we can see that there is a white teacup on the table, and even though it's a white teacup, it looks a little warmer because that warm sunlight is hitting it. So then why would this table be completely desaturated and not warm like the lighting color was? So let's try to fix this situation. So instead of doing everything to the diffuse, I'm going to split the pass apart into raw lighting and albedo. And to do that, I'm going to take the diffuse layer as a whole, and I'm going to take the albedo pass and I'm going to divide it. And we have our raw lighting and our albedo. So the pretend note that I got is that I want the wood to be desaturated on the table and the wall to be also desaturated. So now the desaturation is happening at the texture level. Our lighting is going to be unaffected by this change. So it's going to be warmer on the wall and on the table because of the warm light coming in through the window. So it's a bit of a subtle difference, but I'm going to wipe back and forth. So you can see that one of these is looking a little bit out of place. It's like too cool of a desaturation. And that is because the actual lighting got desaturated. Whereas in this one, yes, the table is desaturated, but it's still receiving some of that warm light because I've separated the color correction from the material texture and the lighting. So it is a bit subtle, but you can see that it's helping with the integration of the scene, because if a gray table was put into that scene, it would still receive the tint of the light. And the same thing with the wall color. So we can see on the right side, the wall is still receiving some of that warm lighting, whereas on the left side here, it is not. So it's helping a lot with the actual integration. And it is maybe a very subtle effect that I'm showing off. The more colorized the lighting, the stronger tint of the color of the light. This is going to be really important because you don't want to change the color of the light. You just want to change the color of the material. Another really powerful technique that you can use by dividing diffuse into raw lighting and albedo is that this albedo is a texture map. And so let's just say we didn't know what we wanted on the painting on the wall, and we wanted to change it after the fact. Well, we don't need to do a round trip back into CG. We could actually just swap that image out. I'm just going to use a regular checkerboard and corner pin it into place. But since we're applying this lighting into the scene, it's basically showing us what this checkerboard would look like as the painting on the wall. So we can see here I'm just switching it out, and it's receiving that lighting information. Now I'm just going to show you that this division will actually give you some artifacting, so it's kind of showing you an outline of this windmill. But we can do a really easy kind of roto shape with a little blur, and we're just going to blur the lighting a little bit just to get rid of some of that artifacting, and it's not going to be too big of a deal for us. It's certainly not going to be something that would cause us to go back into CG. And here the benefit of having the merge divide like we talked about before is I can just select this entire section and I can disable it. And it's basically disabling or enabling this entire separation, change, and combination here. So I'm able to just kind of choose whether I want to be doing this change or not with a simple disable. Here is another example of the importance of where I'm going to put my saturation node. So in this scene, we have this raw lighting with a lot of color information. We have cool light coming from the right side. We have this kind of bounce light that is warm under the table. If I just take my diffuse pass and desaturate some chairs, yes, they're all going to be completely black and white. But if I saturate the chairs on the albedo only, and then look back at this image, you can see the difference in the lighting of the image. So on one side, I'm getting all that bounce lighting, and it's looking like it lives in the scene, and all this colorized light is still going on these chairs, even though they're quote-unquote saturated. So it's just showing maybe a better example than the Blender room was, because it's getting all that nice bounce lighting still contributing to the scene. And as well, you could do the opposite effect. So instead of desaturating the texture pass, I could desaturate the actual lights. So in this fruit ball render, I have some lighting information that is shading the fruit in different ways with some red light and green light. I could just desaturate the lights. So I'm removing some of that colorized light from the scene. And yeah, this could be another way to, say, change the color of the lights or remove some of the saturation from the lights and make it less intense. So we talked before about separating this render into different levels of complexity. The first level was the simple one where we just divided into diffuse, specular, and emission. We added more components to that. We kind of leveled up to level 2, an intermediate level, where we separated things into direct and indirect lighting and direct and indirect specular. And so that was kind of our intermediate level there. Along with a possible variation where we separated the direct and indirect lighting off to the sides. Now, when we introduce more components, we get more options. We get more possible ways to recombine this thing. And I've done my best to just think of different ways that you could possibly recombine these things. Things that make sense, that are structured in a kind of logical way or a useful way in compositing. So I'll just go over them, and no one way or another way is right or wrong. It's just different ways of skinning the same cat. It's all the same thing at the end, as long as it equals back the beauty render at the end. And it's more a matter of convenience, or where you want to place things, or how much space you want, or where you want to do the most color corrections. So here we have level 3, and in level 3, I'm introducing this raw lighting and albedo sections, or the splitting and recombining. And so we have variation 1, which is the albedo change after combining. And what that means is I've combined both direct and indirect lighting first. So first we combine all direct and indirect. Then we take the albedo and we're going to divide the albedo to separate into raw lighting and albedo after the direct and indirect combination. So then our raw lighting change or albedo change would happen here. Then we recombine, we multiply it together, and that is our diffuse pass. And you'll notice we have these bigger buckets of diffuse, specular, emission still. And so it's going to be the same story with the specular. First, we combine specular direct with specular indirect. And then we plus those together, so we have kind of one final specular pass. After that, both of those are going to be using the specular filter, and so we can divide that to get that pure reflection 100% chrome pass, and do our changes to either the specular filter or the raw specular in this point, and then recombine them back together with a multiply, and that is our specular pass. And the emission has no change, so nothing gets split apart there. So it's all happening in the diffuse and the specular. So I'll go over it one more time. First, we build up our passes by combining direct and indirect in both the specular and in the diffuse case. After we've built our diffuse and specular, then we take our albedo and we do our raw lighting with this option to kind of change it. And we can change it after it's already combined. And that saves us a multiplication step. So the second variation rebuild that we could do is the albedo change before combining on a per pass basis. So the theory here is instead of plussing the direct and indirect diffuse together and then doing the albedo divide and multiply, we could just do the divide and multiply per pass. So this would just be dividing by the albedo, and we have our raw direct lighting pass. And the same concept over on the other side, we have the diffuse indirect divided by the albedo, and that gets us the raw indirect lighting pass. We are kind of starting with the raw lighting. Then we multiply those back to normal, and then we plus those together. So basically here, just to show you, if I were to do some sort of change to the albedo change would be visible in the indirect and in the direct. So you could see them kind of still separated out. And then from there, we plus those changes together. And the same story on the specular side. Instead of plussing the specular direct and specular indirect together and then doing the albedo change, we could just turn these into raw passes. So this would be the raw specular direct, and this would be the raw specular indirect. We could do a change, and then we revert back to normal, and from there we plus them together. And that would be our full specular pass. And the third variation I could think of was very similar to the last one, which is that we do the division on a per pass basis. So we have the raw lighting, but instead of multiplying those and then plussing, we just plus all the raw lighting together and then multiply the full raw lighting with the albedo. So that might have been too subtle of a change to catch, so I'm just zoomed out here. And so we have this one where we've done 3 divides and then 3 multiplies, and then we plus them together after everything's put back into place. And then on this side, we've done the division, and then we plus everything together, and then we have only 1 multiply. So we're just multiplying the albedo once on top of the total lighting after we've plussed them together. In my opinion, it would probably be easier to use variation 2, where you have this step and you can disable the entire thing. I think in this version, I think it would be a little bit difficult. I guess we could disable this section here, but it might, it might give you some problems adjusting it later on. I encourage you to go into the script and check out all these variations. So I've basically done these 3 variations per render for the Redshift, Arnold, and the Octane. I've just copied and pasted and changed the shuffle nodes basically because they're all the same structure or workflow. So I encourage you to check it out to see if you can see these subtle differences in how you're going to combine them together. So we can see it here. The further you break things down into their individual components, the more variations or ways to recombine them there can be. So you at your studio might see a different variation than these, but yeah, I've tried to keep it kind of what you normally might see. And still utilizing all of the components that we went over from a simple and intermediate and complex level. So all 3 of these are meant for the purpose of learning, so they have a lot of labels and these kind of backdrops for labeling simple, intermediate, complex, and it's more of a visual guide of what was going on and the thought process behind the recombinations. But that's not necessarily how I would recombine it in a work setting. So I am going to introduce this kind of realistic proposal, introducing all of the components that we've just went over. And this would be maybe my recommended CG rebuild, or certainly one that you would more likely see in production. So I would start with the beauty. I would have an unpre-multiply in all channels. For this render, it doesn't matter, but if you had an alpha channel, it definitely would matter to unpre-mult all the passes. I have this diffuse section. Inside of that, I have the direct diffuse, an option for turning on the raw lighting. So it's off by default, but I have an option to turn it on if I needed it. I've put the albedo in the middle, and that's just to save a little space and look a little cleaner. But yeah, the indirect diffuse is on the right side of that. And so basically, I turn this on to adjust the raw lighting for the direct diffuse, and I turn this on to adjust the raw lighting of the indirect diffuse. And for example, I could just change the albedo in one place, and that would change for both the direct and indirect, but they're still separate. So that's kind of how I like to see it done, so that there's still a level of separation, but you can go to specific areas and change exactly what you need. And of course, we have the subsurface scattering too, which is also getting the possibility to be divided and multiplied by the diffuse albedo, and that all gets added together to be the diffuse pass. Another thing that I wanted to mention was that in this setup, it's assumed that the subsurface scattering is using the same albedo as the diffuse albedo, which is why it's getting divided here and piping into diffuse albedo. But in the scenario that you had your own subsurface scattering albedo by itself, then you would probably want to do this on its own. So you're using the 2 separate albedo passes and do any type of changes that you'd want to this albedo pass. And I know what some people might be thinking about this diffuse albedo being in one place and being kind of piped everywhere, that it looks a little unclean with these lines going across each other. But you might be tempted to, for example, pull out the albedo next to each pass. So you might say, why would I not want to pull out an albedo exactly next to each pass where I need it and do this kind of division multiplication? And the answer is pretty simple. If you were to do a change in one particular area, let's say this one here, you would only be doing that to one of the diffuse albedo. So you kind of be breaking it, because that effect wouldn't be showing up everywhere. You see I'm missing it now from the subsurface scattering. So it's better to have it piping from one place here so that when you do the change, it's doing it to all the passes at once, so you don't have to worry about doing the change in multiple areas. Same kind of idea with the specular. We have the specular section, and on one side I have the specular direct, on the other side I have the specular indirect. In the middle I have the specular albedo, and of course you could like put the albedo to the side or whatever, but it creates a kind of weird thing where you would need to kind of do multiple lines, and I thought if I just had it in the middle, that this dot could go in either direction, so it looked a little bit nicer. That's to each his own though. So yeah, you could, again, turn on the raw section if you need it. So if you don't need it, you can just turn it off or leave it off, and that will save some extra calculation, so the rebuild wouldn't be as heavy to calculate. Although you're not saving yourself that much time. Like turning on a couple of these sections is not gonna break the nuke system or anything. But yeah, it's better to have it off, and then if you need it for any specific reason, you just turn it on when you need it. And of course, the emission is off to the side, and everything just gets plussed together. Bring the alpha from the top, so pipe it around and bring the alpha in, and then pre-mult everything, and you have your final, which should still equal the beauty render. So I'm going to show you the Blender CG rebuild because there was a few differences between that and the fruit bowl render. The biggest difference was that there was no actual diffuse pass or specular pass. It actually started by rendering the smallest components, for example, the raw lighting and the albedo, and you need to multiply those together to get the diffuse pass. So there wasn't a diffuse pass to split apart. You have to start with the smallest components and build up. Which is not a problem. The math is the same. So if you do have the smallest components, it's no problem to shuffle those out first and then build up from there. Another difference was that the subsurface scattering pass, which was on this plant here, it's called translucency, I think, in this one, and it's got a subsurface scattering direct and subsurface scattering indirect, along with its own subsurface scattering albedo pass. And so you want to make sure that you're using, for example, here it says transdir, transint, and transcol, and these three go together. You want to make sure that they get multiplied and combined together, and that you're not using the wrong albedo pass for the subsurface scattering. So there was a slight difference there, where the fruit bowl was using the diffuse albedo, but this one is using its own subsurface scattering albedo. I'm going to use this V-Ray rebuild to show you another issue that you might encounter going along the same lines of what we were just speaking about. I would say that if there is a diffuse pass that you can break apart from the diffuse into separate components like raw diffuse and albedo, I would do that. The problem when you have individual layers as a starting point is that even though this looks correct, so it looks like I've taken my raw lighting and albedo pass and created a diffuse pass with it, if I look at the end result of my rebuild and compare it to my beauty, I'm actually getting some discrepancies. And those discrepancies are coming from this combination of the raw lighting and diffuse. So you're basically not guaranteed to always get the same exact result when you start with the smallest components. It's much better to start with a bigger component, break it apart, and put it back together, because you're kind of guaranteed to get the same result because of the multiply divide equals the same thing. But if you start with two kind of unsure components in this case, you might end up getting a result that you don't want. So it can be a little bit dangerous to start with the smallest components. So you might say to me, okay, that's great to know. I have a problem with my raw lighting and diffuse not actually equaling the diffuse pass. But what do I do? That's the only pass that I have. I don't have an actual diffuse pass. And so here I have the quote-unquote broken render. You can kind of see with this edges that are too bright. Well, with a little trickery, you can get another version of this diffuse pass by basically taking all of the specular or emission, everything else in the scene. So you take every other pass and add those all together, excluding the diffuse, and then you minus that from the beauty. So you're kind of adding everything else up and then subtracting it, and the only thing that you're left with is the diffuse. And if I actually look at these results, you can see there is a difference, and it's fixing those problems that I ended up with. So now I have an alternate version of how to get my diffuse pass. So I have basically thrown all of this into a little group so I don't see it, but you can see it here. It's called diffuse isolation. But all I'm doing inside is doing everything else added together and subtracting to get the diffuse. And so if I'm starting with this diffuse, what I was saying before was it's much better to start from a diffuse that you're confident with to do the divide and get your raw lighting this way. And the logic would be that if I start with a safe version of the diffuse pass and then I divide the albedo and multiply the albedo, well, the division and the multiplication cancel out, and I'm left still with that safe diffuse pass. So I'm not taking any guesswork or anything into it. So I think it's better to start with the larger one and break it into the smaller components and put it back versus starting with the smaller components and then multiplying them together. And if I test this result with the beauty, you can see this is giving me a one-to-one result with my beauty render. So here's a close-up of some of the artifacts that were happening when we were building up the diffuse pass from the smallest components versus the cleaner version, which was we started with the diffuse pass and then we broke it apart and put it back together. So it's cleaning up some of these artifacts. So that's kind of the idea of this CG rebuild. I have the different sections labeled. I'm trying to strike a balance between it being easy to use and intuitive. There's enough space between the sections. It's clear where everything goes and how it's divided or how you can easily use each section. You can feel free to take this and use it either as is or make any kind of changes that you want to use to it. It's just kind of guidance. It's how I would probably go about making a CG rebuild with the diffuse, specular emission, direct and indirect passes, and raw lighting and albedo. That pretty much does it for this video. The rebuild is almost complete. I'm going to talk in the next video what you would do with refractions and true reflections. So yeah, stay tuned for that because that does factor into this CG rebuild. So I guess in the next video I'll have a slightly more complete version of it with refractions and true reflections. But as always, thanks for your patience and tuning in to watch these videos, and I'll see you in the next one.